Hello everyone, welcome to this question where we are given the positions of lighthouse H and two boats A and B. We are also given some bearings of A and B from H, and because the bearing is from H, you see that the north arrow is actually drawn at point H. And let's draw the bearings on the diagram itself. So we will have A, H. This will be the ending line. And for the bearing of A from H is 131 degree. That means from the north arrow, so I'm going to just zoom in. If I were to draw a bearing starting from the north arrow in a clockwise direction to the ending line AH, then this will be 131, the blue color. The bearing, going back to the question, the bearing of B from H is 54 degrees. That means B and H, the bearing is 54 degrees. So I'm going to zoom in again. Then you can see that from the north arrow, stop here. This will be 054 degrees. And therefore, you must be able to see that this particular angle here then is simply 131 degrees minus 54 degrees. Okay, so my angle AHB is very important. We do need to tap on the angle AHB, which is 131 degree minus my 54 degree, 77 degree. And because then, I would then be able to find my AB already using cosine rule. Yeah. So just simply applying cosine rule here for part A. My AB square is equals to 24 square plus 33 square. This one must make the angle 77 degrees. This will be my B and C, minus 2 times this 24 and 33 cosine 77 degrees. Okay, so this will give me a value of 1308.67753. So from here I would then be able to get my AB. It is simply this, the square root of this number. This will give me 36.1756, 36.2 kilometer to 3SF. So part A is done. Part B, we are required to find the bearing of A from B. From B this time round, so you would then see Mr. Tan here drawing a north arrow at point B. Okay. And AB will be the ending line this time round. Starting from the north arrow, draw in a clockwise direction until you reach the line AB, and this will be the angle or the bearing that we are required to find. Okay, so let's take a look at the approach. So I'm going to just zoom in here. By alternate angle, this whole thing will be 54 degrees. So this is what I will label this red color angle here as, which is this whole angle, theta. Okay, I will also need to have this angle here also later on. So my theta is actually equals to 54 degree. Yeah. Later on, I will also need to have this angle here, which we will need to find. So this one, I'm going to call it the angle alpha. Okay. And looking at the approach, you can then see that if we know what is angle alpha, and with this as 180, this portion here, then the bearing of B, A from B, will be equals to 180 plus this angle alpha. Okay, which brings me to this. Then I will then need to find this green color angle. Angle ABH using sine rule. Okay, now that we know what is the angle, what is the length AB. Okay, so the length AB previously we have gathered is 36.1756, and so for part B, which I'm going to write it down here since we are going to focus here. Part B, I'm going to write here. Step 1, there's quite a number of angle we will need to find. We do need to let people know the angle theta is 54 degree because it is an alternate angle. So now our objective for the second part is then to find angle ABH. And I'm going to use sine rule. So sine ABH over 24 is equals to sine of 77 degree over the 36.1756. And from here, I would then be able to get my angle ABH. And from here, I would then be able to get my sine angle ABH, which is equals to sine 77 degree over 36.1756. I'm going to have to multiply by 24. So this will give me a value of 0.6464 269. So angle ABH will be equals to the sine inverse of this particular value, .2727. Okay, now we got our 40.2727 already. Then we will be then able to get our alpha. which is simply 54 degrees minus away my 40.2727. And this will be equals to 13.7273. And therefore, finally, the bearing of A from B will then be equals to 180 degrees plus my alpha. 193.7273. Final answer to 1 decimal place. For angles in degrees. Alright? So that is for part B. Going back to the question, we are now required to find the shortest distance of A to BH. So for part C, I'm going to just do it here. Okay, and at this point I'm going to paste the diagram here again. So the shortest distance of A to BH, that will be actually the perpendicular distance. If I were to draw that shortest distance out, it will be this distance here. In red. (90 degrees to the line BH. Okay, so that would be our shortest distance. So I'm going to name this point here as S. So our objective is to find this SA or AS. And previously we already found out that this is 77 degrees. So now, right, we would have this right angle triangle here, and with respect to 77 degrees, I could then see that my AS as opposite and my 24 as hypo. So with Tuakaso in mind, right, you can then see O and H. I am going to tap on my sine ratio to help me solve this problem. Yeah. So for part C, sine 77 degree will be equals to opposite, which is my AS, over my hypo. So I just need to multiply 24 to both sides in order for me to find the length of AS. So therefore, AS will be equals to 23.3849 to 6 SF followed by 3 significant figures. And this will be the shortest distance from A to BH. Alright, and with that we have come to the end of this pretty long question. So at any point in time, if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.